We have seen containers, how to create a container out of an image, right? How to build a Docker file, how to create an image using the Docker file, right? And we have also seen how to manage the containers using the orchestration tool or container management tools called Docker Swarm, right? So how do we manage the container using Docker Swarm, and how do we create the manager node, and how do we create the worker node, right? And how do we make the communication between the manager node and the worker node, and what happens when one of the worker node goes down, right? So when one of the worker node goes down, it will create the containers, it will move the containers from one of the worker nodes to other worker nodes, right? So this way high availability and scalability is also achieved. So using Docker service command, we can create the replicas. Right, so the containers will fail over to the other physical hosts. So basically we created cluster of Docker host using Docker Swarm. So because of any issue, if one of the machine goes down, it will move the containers to other machine to achieve the high availability and scalability, right? So any questions in this? In Docker Swarm. So Docker Swarm, we do not have to do any extra installation because it comes with Docker. So we just have to install Docker, and Docker Swarm will be available by default because it's Docker native, and we can directly use the Docker Swarm to create the cluster of physical Docker hosts, right?
Yeah, so Santosh, one quick question about high availability. I remember when we were doing that.
We also
Docker,
have other orchestration tools.
I'm not audible.
Orchestration or container management tools like Mesos by Apache, right? And check if you're on mute, you're not audible. Okay. So Mesos by Apache, Kubernetes by Google, and ECS, Elastic, Container Services by AWS. So there are a lot of others. You are not on mute. I think you should be audible.
Yeah, can you hear me now?
Yes, I can hear you, Amjad.
Okay, I think Santosh cannot hear me only. Okay, guys. Okay.
Am I audible?
Okay.
Yes, I can hear you, Santosh.
Okay, if you have some question, type in the chat box. I'm not able to hear. Okay, so these are some of the container tools which are available. Mesos, Docker Swarm. This is a Docker native container tool. Docker Swarm, Mesos, Kubernetes, and ECS. And so today we'll see Kubernetes. So how Docker Swarm, we created a cluster of the Docker hosts. We can also create Kubernetes cluster out of the Docker container machines, right? So this is also cluster of we can say either virtual machines or physical machines. So the prerequisite is Docker has to be installed on all the machines, on all the physical machines, and along with that there are a lot of other packages which needs to be installed which are related to Kubernetes, right? kubectl, and there is something called etcd, etcd. This is the daemon which is responsible for the communication between the different Kubernetes machines, right? And yeah, I think there are some other packages as well, kubeadm or something, which we need to install for the communication between the different Kubernetes machines, right? So once we have all the machines ready, and we can start setting up Kubernetes. So here there is something called master and there is something called minion. So here the procedure is also same. Kubernetes is basically for managing the huge number of clusters. Again, how Docker Swarm works, Kubernetes also works in a similar way, but Kubernetes has got a lot of flexibility with respect to feature. So Kubernetes has definitely got some advantages over Docker Swarm. Something like maybe with respect to scalability, it can scale up to thousands of containers, right? So it can run thousands of containers and it can take care of the high availability. Okay. No, VM it will not manage. It only manages the containers. But Docker Swarm we create in between the physical clusters, in between the physical machines. But Kubernetes we can also create between the cluster of virtual machines or physical machines. It is always advisable to create a cluster of physical machines because in a physical machine there can be multiple virtual machines, and if the physical machine goes down, all the virtual machines will go down, right? So it's always advisable, recommended to create cluster of physical machines. So we take 4 or 5 physical machines, and then on top of that install operating system, on top of that install Docker, then install Kubernetes, then create a cluster out of the all these machines, so that we can create containers on all these machines, and we can create a cluster and we can deploy, right? So what is the advantage here? Even if the machine goes down, the container on the machine will move to the other machine, and here we'll not take care of which machine runs which container, right? In Docker Swarm also we never specified this container has to be started on this node, right? It is the manager which decides, right? So here on the manager we tell like I need these many containers and this is the desired state, and it is in Docker Swarm it is the manager who decides on which node which container has to be running, right? So it's all decided by manager. So load balancing and based on the incoming web traffic, spinning up the containers. So all those things are done by the manager. Something like detecting, because detecting the software or hardware errors. Who does this? All these things are done by the manager, right? So manager knows, and if you just say Docker Swarm node list, you can see the status as ready, not ready, right? So that if any of the container goes down, this manager always checks the heartbeat of the container. If the container goes down, manager will make the status of the container as not ready, and it will move that container from that machine to the other machine to take care of the high availability. In a similar way, Kubernetes also behaves. It also has a master. It also has minions. We can have multiple minions. Okay. So compared to Docker Swarm, Kubernetes setup is complex because we need to install a lot of packages. We need to do a lot of setup, right? And so here also what we specify, what we define is we install packages on the master, we install packages on the minions, and there are a lot of configuration files that need to be changed on both minion and master. Something like we need to notify minions like this is your master, and on the master also we need to make some configuration changes. Mostly in etc Kubernetes conf directory, there are some files and etcd, and there are some configuration files which we need to modify on both master and minions. And once this is done, there will be a communication established between the master and the minion, and then there is something called pod that we need to start. So this is the basic building block of Kubernetes, right? So pod can contain one or more containers, right? So what we do is, so basically we have pod defined. Pod is defined in the YAML file. So we write a YAML file for the pod, and let us say here we define the pod. So pod is something like, I want these many containers with this image and with this replicas, like that we define the pod using the YAML file. And there is something called Kubernetes controller, or there are some other process like scheduler, and these are the minions. Let us say minion 1, minion 2, minion 3, right? So we just define the pod, and what do we give is we give the desired state of the pod, right? So I want these many containers to be running. We'll not specify on which machine it has to be started, right? It's all managed by the Kubernetes master or Kubernetes controller or the scheduler, right? So we just define the desired state of the pod, and it is all taken care by the master. So if in case, let us say there are multiple pods running, pod 1, pod 2, pod 3, and because of any reason, if minion 2 goes down, right? So immediately pod 2 will be moved to pod 1 or pod 3 based on the resource utilization, and it is all taken care by the Kubernetes master, right? So basically what do is we do the configuration, we install the Docker, we install the Kubernetes, we create the cluster, we make all the configuration changes. Once it is done, then we define the pod. So this pod is written in YAML file. Here we specify how many containers we need. So this is the kind of a smallest unit of the Kubernetes building block, and here we specify the number of replicas and what is the image and all that stuff, right? Yeah, it's a collection of containers, one or more, right? So we call it as a basic unit of containers. Okay, so we can have multiple containers. So all these multiple containers will share the single resources. They'll have a single IP listening on different ports, right? So single pod can have multiple containers. Containers share the IP address and resources, right? So this entire pod will be running on a single host, right? So if something goes wrong, it will be moved to the other host. Yes. Okay. So this is the Kubernetes. We can also define something called label. If we have thousands of clusters, thousands of containers, it is really difficult to identify what is what container. So right, so we can label the container, right? And using the selector, there is something called selector tag. Using selector, we can identify which is a container. In the sense, we can list out from the list based on the label, we can select. So there are two tags, one is label, the other is the selector, right? Okay, so we'll see how to create the containers, Kubernetes, how to install Kubernetes. So I have, I just created 3 new Vagrant machines. Okay, so first to set up installation and configuration. So what do we do is take 3 machines, create 3 Vagrant VMs, configure one as master, other 2 as minions, right? Then so there are some procedures to be followed. Okay, so we'll just log into the containers. So this is master, this is minion 1, this is minion 2. So there is no Docker now. Docker is not installed at all. So we'll start from so first we need to install NTP. NTP is the network time protocol. Yeah, this all are CentOS Vagrants. Install NTP on all the nodes. Why do we need NTP? NTP is network time protocol. So that is to have time sync between all the machines, so that all the machines will have the same time, right? So install-y NTP is the command. So I'll go and execute on all the machines. Okay, then I need to start the service and enable the service. Installed. I just installed NTP. NTP is network time protocol, and I'll just start the service and enable it. So we can also check systemctl status NTPD. So it is running. Okay. Then what is the next step? I install NTP, and we need to add etc hosts, all the IP addresses on all the machines, so that we can communicate using the host name, right? So I'll just go to, let me get the IP. Okay, so this is my IP. So I'll go ahead and add in etc host. So this is my master. So this is the IP. So this is master, and this is minion 1. And then IP ADR. So this is minion 2. Right, so I'll just add it. Let us see if I can ping based on the host name. So ping minion 1. Sorry, minion 1. Okay, so it's pinging. Ping minion 2, it's pinging. So I'll just add all these things to other hosts as well. Remove everything and put only 3 host names and IPs. Okay. So just added information about the IPs to all the 3 machines, right? Then we need to download the packages. So to download the packages, I need to have the repository, right? I need to download the Docker. I need to download the Kubernetes as well. So for that, I have added a repository. So let me create a new repository, right? So open this file and give the information about this repository so that it will download the packages from the Kubernetes site. Okay, so I'll just add this. So this site centos.org and x8664.os. So this has packages related to Kubernetes. So that I'm going to add to all the machines because we need to install the packages. Third node. Minion 2. We already added. Okay, 2 we added. 1 we didn't add. 1. Okay, so I just added the repository information. Then let us try to enable the repo and install the packages. So this will install Docker, etcd, and all those packages which are required to set up Kubernetes. Is this clear so far? Is this clear so far? We just installed NTPD and we created the repository, created Docker repository, Docker and Kubernetes repository, and install the packages, right? And then, okay, so this is yum install is the command. Yes, yum install is the command. Yum install and the packages names. etcd, Docker, Kubernetes, and all those packages it will install. All the dependencies will install. etcd, Kubernetes, Docker. Okay, it's still installing. Once it is done, then yeah, sure. Then we need to configure the master. So for the first time, we need to configure the master. So how do we configure the master? Again, there will be some configuration files that we need to change, right? So so here we need to specify in the master. We need to specify from which nodes it has to allow the connections, right? To allow the connections from minions, right? And the port it has to use the IP address it has to use. So all this stuff we mention in the master configuration. So there will be a file, there will be two files that we need to change, right? So it is completed. So let us move to the next step. So configuring the master. So this is the file Kubernetes config, and there will be some parameters which we need to modify. Okay, so this is my master. So this is the file etc Kubernetes configuration file, and here, so this and all we can leave as default, but this we need to change it. Kubernetes master cube underscore master is equal to master 127. We want to allow, here we specify something called master. Instead of 127 we specify it to master. Okay, this should be master. Okay, master 8080, and we also need to add one more line, because it creates something called etcd server on the master. This is for the communication between the master and the minions. Okay, on the port 2379. By default it listens on the port 2379. Right, so we just added two configuration changes. One is kube master and kube etcd servers, right? And this is the change which we have done, right? And the next thing is we need to modify the etcd conf file, right? Go to etc Kubernetes, and there is something called etcd, and there is something called etcd.conf. This also we need to modify. So there are two sections here. One is the member section, the other is the cluster section. So here we need to modify one thing in the member section, listen client. So here it is only listening from the local host, but we want to allow from all the machines. So to allow from all the machines, just specify 0.0.0.0. This indicates that allow connections from all the minions, right? So listen to clients. And here there will be also similar way in the cluster section, that also we need to modify localhost to all the machines 0.0.0. Okay, and save this file. So we modify two things. One is the etcd listen client URL in member and advertise client URL in cluster. So this is to allow connections from all the machines. Earlier it was only local, now we made it 0.0.0, indicating that allow connections from all the nodes, right? So while configuring the master, first we changed etc Kubernetes and then config. This is the file, and second file is etc etcd.conf, and third file is etc API server. What is the path? Kubernetes API server. Okay, so let me go to etc Kubernetes API server. So here also we need to do some more configuration. Kube API address. Again here 127 is there, that we need to modify it to 0.0. This is to allow from all the machines, right? And Kube API server. etc the server port 8080. Where is port 8080? Okay, this we need to uncomment. Cubelet port also we need to uncomment so that it listens on the port 1250. So here we have cube etc servers. So this also we need to change it to 0.0. Okay, and yeah, I think that's all. Remaining all default. You can just save this, and with this the master configuration is completed, right? Then we need to execute these commands. So this will enable the etcd API server, controller manager, scheduler and all, and it will start. Let us see if this will run. Okay, so this is started. It started etcd, Cube API server, Cube controller manager, Cube schedulers. So these are all the processes which are responsible for managing the cluster nodes. Okay, so let us see if anything is failed. Active. Okay, all four are running. Okay, let me see this way. Grep for running. Okay, all four are running. Okay, so we have to make sure that all processes are running after completing the master configuration, right? So with this, master configuration is completed, and start all the process. Is this clear? So we need to repeat the steps on minions. Again, we need to modify the configuration files. So again, we need to modify the Kubernetes config file. So I'll go to minion 1. So change the cube master. So here I need to specify the master as, instead of 127, I specify master. Okay, so for the minion, we are informing something like this is your master. Okay, managed by, go and manage by the master. And also we need to add another line. This should be master. Okay, so once this is done, then we need to change kubelet configuration. So these minions are also called kubelets. Okay, so first we modify the config file, then we are modifying the kubelet. So in the kubelet IP address, this has to listen from all the nodes. So I'll change it to 0.0. And comment the port. Host name, and here we need to give the host name of the minion, that is minion 1, right? And then again here API server as master. This we do not have to pod infrastructure container. Yeah, kubelet in minimum is same. Okay, so rest all things we can leave as it is and save this. Okay, then with this the minion configuration is completed. We need to stop. So there are some processes which are running also on minion, that is kube proxy, kubelet and docker. So let us see what is the status. I just started them, enabled them, and I'll check the status. So all three should be running. Okay, so all three is running. So this is the configuration which we need to make on the minion, right? etc kubernetes config and etc kubelet, Kubernetes and kubelet, right? So these are the configuration changes which we have done, right? And then start the process. So this the same thing I need to repeat on the second node as well. So I did it on minion, I also need to do on the minion too, right? So etc kubernetes config change the kube master, specify master, and add another line. Okay, save it. Make sure all the inverted commas are copied properly. Okay, then go to etc kubernetes kubelet. Okay, so here kubelet IP address we modified to 0.0. Okay, we uncomment the port, and the host name we specify as the actual host name of the minion 2, right? And API server as the master. This we will comment and remaining all default, and we just execute the same command to start the process. So make sure all the processes are running. Okay, so with this minion configuration is also complete. So we did the same thing on all minions. Right. So basically, it's like we have taken out that 127.0.0 default IP address to master IP address, and also we have specified, we allowed the master and the minions to listen for the request from all the nodes. Instead of specifying one IP, we have specified 0.0.0, indicating that allow connections from all the machines. Is this clear so far? We configured the master, we configured the minion. Is this clear so far? And then now if I go to master and execute kubectl. So kubectl is the command which we need to execute. Kubectl on the master. Yeah, a lot of configuration and it's complex. Get nodes. Okay, so when I execute kubectl get nodes, it is giving information about the minions which we added, 2 nodes, and the status is ready. So it will continuously check the heartbeat, and if in case if any of the container goes down, it will change the status to not ready. Right? So our Kubernetes configuration is complete, and with this we can see the get nodes command that will give list of all from master, we'll get list of minions. Is it clear? Yeah, we still have to create containers. We just did the configuration of Kubernetes cluster. So we created cluster of Kubernetes. We created a cluster of Vagrant VMs, right? So we have taken one of the machine as the master, the other machines as the slaves, right? And we call them minions. And then we installed the packages, did a lot of configuration changes, and master and minion also we identified, and we have given the information about the master and the minions, and master is able to detect the minions. Yeah, minion 1 and 2 are something like slaves, something like worker nodes. This is like manager node. So here we can have any number of slaves. So that's the advantage, right? So we can have thousands of containers running from single master, right? So now we need to create the part. So there are some commands to describe the nodes. I think that there is no limits. It's like we can have, it's highly scalable. Kubernetes is highly scalable. Okay, so Google runs thousands of containers. Describe is to check all the details about the nodes. Okay, so there are a lot of commands available. -go or -capital. kubectl getter get nodes. Okay, I think there's some typo. So now we can create the, we have to create the containers, right? So I'll just create test directory. On the test directory, I start writing my YAML file. So this YAML file is to create the, so we have created the master, we configured the master, we configured the minions, and we are able to get the nodes list from the master. That indicates that the configuration is working fine. Now create the part. So to create the part, we need to use the YAML file. So in the YAML file, we need to specify what is the pod image, right? So replicas, we need to specify label, we can specify selectors, we can specify. So all those things we can specify. So here, this is the convention which we need to follow. So I just say nginx .yaml and I specify the code here, right? So here API version is v1, starting version v1, and then kind is pod. So here we can have different kinds of what do you call units. So here this is pod. We have also other ones, extension or something, we'll see. So metadata name is nginx. Specifications, I want to create a container with the name nginx, and the image is nginx 1.7.9. So this is something like creating a web server, right? Web server with nginx or web server with Apache or MySQL database. We can create any container using this, and I want to have that on the port 80. So I want to expose the port 80 from the container so that it can be accessed outside. So these are the things which I mentioned in the YAML file. So this will create a single container from this YAML file, right? So API version, kind, metadata, and specifications about the containers. So these are the container specifications. So this is the desired data. So something like I tell I want nginx container to be created with the image, this image, and with this the version 1.7.9. Okay, nginx image has to be downloaded, and it has to create a container out of this nginx, and it has to expose the port 80. Yes, I'm trying to create the containers. But I'll not specifically tell create container on minion1 or minion2. I just specify this is my desired state. So it is decided by the Kubernetes master to decide on which host this container has to be created, right? So I can also add a tag called replicas, wherein something like 4 or 5, if I give 4 or 5 containers will be created, right? Okay, so let us just save this. Pod is a collection of containers. Okay, so when we move when the machine goes down, it will move all the entire unit pod 1, let us say pod to from host 1 to host 2. If the host 1 goes down, if the minion 1 goes down, the entire pod will be moved from minion 1 to minion 2, right? So we have created the YAML file to create the pod. So this YAML file, yeah, all containers are bundled inside the pod. So pod is like a collection of containers. Manually, we don't do anything. It's all done by the master. We don't even specify where to run the pod. High availability, failover, all these things, scalability are done by the master itself, right? So what's the command? kubectl create -f and the YAML file. So this is the command to create the pod. Kubectl create -f nginx dot YAML. So this will create the containers. Create the pod and the containers. Okay, so we can also see kubectl get pods. So there are no resources. Get nodes. Yes, so yeah, under one slave, it's a collection of containers. So we have 2 slaves. We have no pods. So let us try to create a pod. So kubectl create -f. This is a file which we need to specify, and nginx.yaml. Okay, so error from the server, error while creating nginx.yaml. No API token found in the service account. So this is actually a bug from Kubernetes. So for that there is a workaround. So we need to generate a key. And we need to add this etc Kubernetes API server. So this we need to add at the end. So basically we are asking to use this key. And in the controller manager also we need to specify this. So this is a bug from the Kubernetes. Okay, so I did the correction and then I just create the pod. Yeah, we did it on the master. Ideally, it should show the index.html from the Nginx web server. So there is some path where we can modify the. Okay, let us see this tomorrow. So we just created a we installed Kubernetes master minion, and we did the configuration, and we created a pod using the YAML file. Any questions in this? I'll send that. I think, yeah, it's there in the other laptop, and I'll get it. Yeah. Any questions in this? In Kubernetes? So next, there are things like how to label, how to create replicas, what happens if the machine goes down, and how to use the selectors. Okay. Is this clear? We'll create multiple containers using the same YAML file, and then we'll try. Yeah, sure. We'll stop here. We'll meet tomorrow, same time, and then what is that? Another thing is remaining is VPC. Okay, so that's end it. Workout bug. Yeah. Okay, so is this clear? We just configured Kubernetes out of 3 machines. We created a cluster, 1 as a master, 2 as the minions, and then we did a lot of configuration changes, and we also installed all the software required: Docker, kubectl, kubeadm, kube API server, kube scheduler, and then we created a YAML file and we have specified the desired state of the container, and then by default from the master, if you execute kubectl, it has created a pod and the container on the minion. Okay, any questions? Okay, then we'll stop here. We'll meet tomorrow. Did you copy the notepad? Okay, thank you. Bye-bye.